What do product and sum types have to do with data modeling? By the end of this episode, I hope to answer that question because I missed it when I talked about product and sum types the last time. Hi, my name is Eric Normand, and I help people thrive with functional programming. So a few episodes back, I talked about product and sum types and explained what they were. So I'm not going to go over that again because, you can just go listen to that one and get it all. But I did get a couple questions about why I mentioned them and what they have to do with data modeling at all. And I realized I had explained what they were, but I totally forgot to talk about why you would want to use them at all. Okay, so now I'm going to try to explain that. So when you have a domain that you're modeling, there are let's just look at a simple case. All right, so you're modeling this domain, and there's certain cases that you have to capture. And let's say that there are 10 cases. Okay, now one thing you could do is simply enumerate all of the cases. Let's say it's 10 states that the system can be in. You can just enumerate them. So you have one type that has all 10 cases. Okay, so that would be a sum type that has the 10 different constructors, let's say. But there's other ways you can hit the number 10 as well, right? So you could have two 5s, right? So you could have two types, let's say a 5 each, and then have an either between them. An either is a sum type, so it's going to sum the 5 and the 5, right? So that gives you 10. Now another way you could do it is you could have a 2 times 5, so not 5 plus 5, but 2 times 5, meaning you use a product type where the first, let's say a tuple, right? A tuple is a product type. So the first element of the tuple has 2 cases, and the second element has 5. So now you've got the 2 times 5, and you've got 10 again, right? So this is the kind of thinking that you can do once you realize that there are these product and sum types that you can use, right? Now, why do you want to target the number of cases exactly? Well, I've done a very detailed analysis for my book of this. It's not going to be in the book because it's kind of boring. But if you've got too many cases in your domain model, that means a case that doesn't really exist in the real world, but it exists in your software, like it's possible. Like let's say you did 5 plus 6, and so that's 11. So there's 11 cases, but one of them shouldn't be used. At some point, you're going to either use it or have like a conditional to make sure it's not being used, right? And conditionals add complexity to your code. So if you have extra cases, you're adding complexity. Now, what if you had 9 cases when there's really 10 cases in your domain? If you only have 9 cases in your code, that means that you're probably going to be overloading one of those cases to make up for it, right? So you're probably going to be using one of those cases in 2 different ways, and your code is going to have a conditional to figure out which one of the cases it really should be. Okay, so in both cases, in both of those situations, you are missing the perfect fit between your domain model and the domain itself, and adding complexity because of it. Okay, so an example of something, I mean, just a very simple and almost silly example of a time when you might have a misfit is, and this happens a lot, you have something like you're reading a sensor, like a thermometer, and sometimes when you do a read, it doesn't give you a number, but the API you're given doesn't have a way to not return a number because it's C or something. So the return value is always a number. So what does it do? It overloads 0 to be either 0 or oops, I didn't get a reading when you asked me for it because, you know, the sensor was down, or you're trying to ask too quickly or something like that. So it's overloading 0 because there's this case that doesn't fit within the type. The type that they chose was int, and there's this extra case that they want to represent, and they had to and that's not in the type, and so they had to overload one of the values of int with this number. Now maybe they could have chosen a better number, like you know, something that you're unlikely to ever read, like -1,000,000 or something like that. But even still, even if you had that, you still have a conditional that you're going to have to deal with. And you would probably have to, you know, if you wanted to convert it to a better type, you'd still have a conditional in there. At least it would be in one place in the conversion code. But these things happen in real life. I have a memory of a system where you could accept both credit card and PayPal. And with credit card, they were using Stripe, and PayPal has its own ID. So Stripe's ID and PayPal's ID were stored in the same database table. And so to know if someone was a Stripe customer, it would take that ID and run a regex on it to see if it looked like a Stripe ID. And to see if it was PayPal, they would run another regex on it to see if it looked like a PayPal ID. So everywhere where you had to use this, you wanted to get the ID or figure out what to do with it, you had to run this regex on the field. Instead, they should have realized that if they had known about product and sum types, they would have realized that this is actually a sum type, where instead of overloading this one field for the 2, we should have an either PayPal or Stripe or some other system like that would better fit the domain. And in fact, I have heard that in a recent upgrade, they have made that change because it was causing them a lot of pain. A lot of code which was just checking for, you know, is this a Stripe ID or a PayPal ID? Very duplicative code. Okay, so if you have these product and sum types, notice you've got plus and times, right? Product is times and sum is plus. You're able to target any number that you want in different ways, in multiple ways. So you, like I said at the beginning, you can have all 10 cases just enumerated in one type. Or you could break it up into 2 5s and sum them. Or you could break it up into 3 and 7 and sum them. Or you could have 2, 6, and another 2. There's all sorts of ways that you can break it up. And that's what the product and sum type gives you. It gives you this flexibility to really dig deep into the domain and model it both correctly, because you can just do the math and know, yes, these have all the possible types. I mean, all the possible cases, and I'm not missing any, and I don't have any extra, and you have the flexibility to choose whatever way you want it. So if you want to break it down into 2, like I said, 2 5s, and then sum them, you can do that. You don't have to have the 1 10, right? If you want to break it down, like I said before, into a 2 and 5 and multiply them, then you can get the 10. You can do two 4s and then add a 2, right? So, I mean, 2 times 4 and then add a 2, right, to get the 10. So there's once you open this door, you can see how easy it is to target a specific number of cases, and lets you analyze, whether you're actually getting the right number of cases, and avoid the problems of, using a product type and not realizing that actually, let's say you wanted to target 9 things and you used a 2 times 5, thinking, that 10th one, I'm never going to use it, it's going to be fine. You don't realize the problems. What if you did 3 times 4 and you had 3 extra cases? Like, that's even worse. And you're just adding complexity to your software. You're creating conditions where a value is possible to be created, but not meaningful in your domain. And so that you're just asking for trouble. If you can avoid it, you might as well avoid it at the beginning. Okay, so just to recap, we have product and sum types, which let you easily model any particular number of cases that you might have. And they let you easily analyze how many cases you do have. So they're very useful for having all the flexibility to target particular numbers, and being able to know how many you actually have. So you have both. It's both easy to create and very flexibly, and easy to see how many you have. So an analysis. All right. If you like this episode, you should go to lispcast.com/podcast. There you'll find all the past episodes, including the one where I explain product and sum types, and all the other ones with audio, video, and text transcripts. You'll also find links to subscribe and to find me on social media. So get in touch. Love getting these questions. I love answering them on the podcast. My name is Eric Normand. This has been my thought on functional programming. Thank you for listening, and rock on.